Hey friends, welcome to NIKRA'S Expert Learning. In today's video, we are going to discuss about admixtures. But before starting today's topic, if you like this video, please do like, share and comment to the channel because your subscription would greatly motivate me. Only 0.5% of viewers are subscribing to my channel, guys. I would like you to increase this count. Please do subscribe to my channel, guys. Coming to today's topic, we are discussing about admixtures. It is defined as a material other than cement, water and aggregates that is used as an ingredient of concrete and is added to the batch immediately before or during mixing. So whatever the additive we are adding other than the cement, water and aggregates, we are calling that term as admixtures. Okay. Additive is a material which is added at the time of grinding cement clinker at the cement factory. So whenever we are adding this cement clinker in the grinder, at that time we are adding this material called additive. So it started in the year 1940. This is the difference, guys. So admixtures is something which we add during the mixing of the concrete, but additive is a material that is added during the manufacturing of cement itself. Okay, it started in the year 1940. There are the important ingredients in high performance concrete. So whenever we need performance to be increased in the concrete, we would be adding admixtures generally. Let us now see the uses of admixtures. To modify the properties of mortar or concrete, such as to improve workability. So let us now see what is workability. Workability, as per IS code 6461 part 7, defines workability as: workability is the property of concrete, that is the ease with which it can be mixed, transported, placed and compacted easily. So this is the definition of workability as per this IS code. This is one of the very important properties of fresh concrete. I would be placing the link of this fresh concrete properties in the description below. Please go check that video if you find that useful. In that complete explanation of workability, the requirements of that fresh concrete, whatever the fresh concrete property should be satisfied, are clearly mentioned. And also to alter the setting times of cements. So whenever we have to transport the cement to greater distances, whenever the hauling distance between the production site and the construction site is more, at that time we have to be increasing the setting times. So that is where we have to use this admixtures. And whenever we are saying altering the setting times, it is of two types. First of all, accelerating, and second, retarding. Accelerating is early setting of cement, where retarding is we are retarding this setting time of the cement. Okay. However, I will be explaining more clearly in the upcoming topics. Strength development, improvement of durability. Durability is nothing but the life of the structure. So whenever we are adding these admixtures, it will increase the life of that concrete. To control alkali aggregate reaction. So first of all, let me explain you what is this alkali aggregate reaction. So the alkali aggregate reaction is nothing but the reaction between the aggregates and the alkali content in cement. So what are the causes of this alkali aggregate reaction? The causes are the reactive type of concrete. Whenever the aggregate we are using in the concrete is of reactive type, this alkali aggregate reaction would be accelerated. And high alkali content in cement. So whenever the alkalis in the cement content are greater than the required amount, there would be a chance of this acceleration of this reaction. Availability of moisture. So depending upon the moisture available in the concrete, the degree of this reaction would be explained. Optimum moisture content. So these are all the factors contributing towards this alkali aggregate reaction. And next, to control the heat of hydration. What is this heat of hydration? Heat of hydration is the heat generated because of the hydration of the cement. So whenever we are mixing the concrete, we would be adding some water to that concrete, right? So because of this addition of water, so the molecules, the cement molecules will get hydrated. That is, the water will enter into the cement. So there is some generation of heat because of that hydration. That is the heat of hydration, and that is why we are calling this as an exothermic reaction. Whenever heat is released because of some reaction, we are calling that as exothermic reaction. At present, 70 to 90% of concretes made consist of one or more admixtures. So generally we are using the concrete only with the admixtures. Let us now see the classification of admixtures. Generally, they are classified as chemical admixtures and mineral admixtures. And again, the chemical admixtures are subclassified as surface acting chemicals or surfactants and set controlling chemicals. These surface acting chemicals or surfactants are broadly classified as air entraining admixtures, water reducing admixtures, plasticizers and superplasticizers. In general, admixtures performs more than one function. So whenever I am saying water reducing admixtures, it doesn't mean it only reduces the water content, but it also has other functions to perform. Okay, so let us now see the detailed explanation of this. Coming to the first one, we have air entraining admixtures. Air entraining admixtures facilitate the development of a system of microscopic air bubbles within concrete during mixing. Because of the development of these microscopic air bubbles, there are some advantages, like they increase the freeze-thaw durability of concrete, increase resistance to scaling caused by these chemicals, and improve workability. So here they are firstly increasing the freeze-thaw durability. Firstly, let me tell you what is durability. Durability is increasing the lifespan of that member. Okay, freeze-thaw is alternative freezing and thawing cycles, that is, suddenly the temperature is reduced and suddenly it is increased. So because of this temperature fluctuations, there is development of the freeze-thaw action. So even in that cases, they increase the durability. So whenever these microscopic air bubbles are there, during the freezing and thawing, whatever the voids between these particles of this concrete would be there, they would be filling up by the expansion and contraction of these air bubbles. And also they increase the resistance to scaling caused by these chemicals. Whenever the chemical action is there, it will also be acting against them. They improve the workability. And in the surface acting chemicals, we have water reducing admixtures. It is again subclassified as plasticizers and superplasticizers. So plasticizers will reduce the water content by 5 to 15%, and whereas superplasticizers, they reduce the water content by 30%. So that is why we call this plasticizer as water reducing admixtures and superplasticizers as high range water reducing admixtures. So let us now see what is a superplasticizer. Superplasticizers, distinct from water reducing admixtures, reduces water by 25 to 35% by weight. So here whatever the weight of water is there, that can be reduced by 25 to 35, increases 24-hour strength by 50 to 75%. So because of the addition of the superplasticizers, we are increasing the early strength of the concrete. Okay, it reduces the water content by 25 to 35%, whereas the plasticizers will reduce by 5 to 15%, and it interacts with C3A, that is tricalcium aluminate. Hydration retards. Here there is retardation of the hydration. Okay, so can be used down to 0.2 water cement ratio. So whenever very less water cement ratios are there, even in that case it can be used. Coming to the effects, warps around the cement particle gives them high negative charge so that they repels, resulting in dispersion of cement particles, resulting in improvement in strength and workability. So whenever we are adding superplasticizers to the concrete, it warps around the cement particle. So it gives some negative charge so that they repels, resulting in the dispersion of cement particles, resulting in improvement in strength and workability. So because of this reaction between the cement particle and the superplasticizer, there is some improvement in strength as well as workability. Okay, and we have some types of the superplasticizers that are generally used in the concrete. They are sulfonated melamine formaldehyde condensate, sulfonate naphthalene formaldehyde condensate, modified lignosulfates, sulfonic esters, carbohydrate esters. So out of all these, two types are generally used and referred as melamine based and naphthalene based. So as we are saying, the sulfonated melamine formaldehyde condensate, it is based on melamine. That is why we are calling as melamine based. And here we are calling this as naphthalene based. Okay, next let us see the set controlling admixtures. That is the second part of the set chemical admixtures. That is set controlling chemicals or admixtures. We have completed the surface acting chemicals or the admixtures. We call them as surfactants. Next, let us see set controlling chemicals. So they are generally classified as accelerators and retarders. So as the name itself explains, this accelerates the setting and this retards the setting. Okay, let us now see everything in detail. Coming to the first one, accelerators. So here, accelerating admixtures. Accelerate setting. So it is early setting of the concrete, because of which there is early strength development of the concrete. Okay, in concrete there is early strength development. Commonly used accelerators. So generally we use calcium chloride. Accelerates the hydration of C3S, that is tricalcium silicate. This is a part of Box compounds which I will be explaining in the upcoming videos. Guys, if you are liking this video, please do subscribe to my channel guys, it would greatly motivate me. Only 0.5% of users are subscribing to my channel. So coming back to this topic, calcium chloride. It accelerates the hydration of C3S, tricalcium silicate. Increases resistance for erosion and abrasion. See, abrasion is nothing but the rubbing action of the load acting. More rapid rise in temperature. Used in low temperature concreting. So whenever we have to do the concreting work in low temperature conditions, we can go for this calcium chloride as accelerator, because it is used also to raise the temperature. Defects. Steel gets corroded. Because of the increase in the temperature, the reaction would be accelerated, wherein the steel gets easily corroded. Less sulfate resistance in lean mixes. Lean mixes is which is not strong. Increase in alkali aggregate reaction. More drying shrinkage. This is a type of shrinkage wherein we have 4 types of shrinkage which I will be explaining in the coming videos. Sodium chloride. Similar to calcium chloride except for less strength at 7 days. Next, barium chloride. Only in warm conditions. So whenever there are warm conditions for us to concrete, in that case we will be using this barium chloride. Next we have calcium nitrate, calcium nitrite, calcium formate and sodium formate. So generally these are the types of accelerators we use. Okay, next let us see the retarding admixtures. And even in every case I have explained you with examples. Okay, also for accelerators, retarders, the superplasticizers, air entrainers, I have given you the examples. Okay, now let us see the retarding admixtures. Delay setting time. Some retarders also act as water reducing agents. Early strength gets reduced. As we are retarding the strength to be developed, early strength is very less. Okay, whereas in accelerators it is vice versa. That is, it is opposite to that case. Okay, increases plastic shrinkage because of delayed setting, but drying shrinkage is not affected. See, whenever we are talking about accelerators, here the drying shrinkage is getting affected, but whenever we are talking about the retarding admixtures, only the plastic shrinkage is getting affected. Incorrect usage greatly affects setting and hardening. So whenever we are not using it correctly or in the correct proportion, there is some drawback in case of setting and hardening of the concrete. So let us now see the examples of retarders. Sugar. See, generally sugar is a very well example of this retarders. Next we have carbohydrate derivatives. Soluble zinc salts, soluble borates and methanol. Dosage of set controlling admixtures is very important. As I already told you, even the quantity and the quality, the timing is very important whenever we are adding these retarders. Some of the admixtures act as retarders at small dosages, like 0.3% by weight of cement, but acts as accelerators at large dosages, 1% by weight of cement. So remember, whenever we are adding the retarders, it is very important to check the quantity. Okay, and also whenever the accelerators are used, it is used at large doses. Generally, like was 1%, and here we are using 0.3%. And superplasticizers and plasticizers, I have explained you differences. And also regarding the set controlling admixtures, we have some drawings. Like this is the time of set in the y-axis, and on x-axis we have admixture concentration. So this is a very important diagram regarding the admixture concentration. So first of all, whenever we are drawing this, remember the axis and on which axis what we have. Coming to the first element, it is CaSO4 and 2H2O, and the second one, it is calcium chloride and CaNO3 twice, K2CO3 and NaCO3 as third element, and the fourth one we have surfactants, that is gluconates, lignosulfates, sugars, and the fifth one we have salts of formic acid and true ethanolamine. Here, this is the diagram for that. And next let us see the last element, that is mineral admixtures. Till now we have completed the chemical admixtures, that is surface acting chemicals, all these 4 and next in this we have set controlling chemicals, that is accelerators and retarders. We have completed these 2 elements. Next let us see what is a mineral admixture. Coming to the mineral admixtures, they can be a byproducts of industry or agriculture. So whenever it is given by the agricultural phases, we are calling this as the agricultural byproducts, and whenever we are getting the byproducts from industry, we are calling that as industrial byproducts. It can be silica fume, fly ash, blast furnace slag. And next, in the agricultural byproducts, we have rice husk ash, that is whatever the rice peel is there, we are turning it out into an ash. Okay, so that is what we call as rice husk ash. One of the above silica fume and rice husk ash are the highly reactive pozzolan. Okay, the silica fume and rice husk ash are highly reactive pozzolan. So that is it for this video, guys. If you like this video, please like, share and comment to the channel, and don't forget to subscribe to my channel, guys. Please increase the subscription count, guys. It would greatly motivate me. Thank you for watching this video, guys.